Hello guys, and welcome back to another episode of chemistry. All right, and in this class, in this episode, we are going to be looking at the concept of unsaturated, saturated, and supersaturated solutions. Saturated solutions. Okay, so I'm going to be looking at the concept of unsaturated, saturated, and supersaturated solutions. Okay, I discovered that a lot of students confuse this concept, and a lot of questions come out under this topic in JAMB. A lot of questions. So please, you have to carefully understand them and apply them to daily life. Okay, so if you just reason what it is, then try to see how you have encountered it before, right? So it's possible that one of you have put salt inside water or sugar into water before. Okay, so that is that for that. Okay, so saturated, unsaturated, and supersaturated solution. Before we continue, please like this video. Liking this video will make other students easily find these videos and learn also like you are learning. Please, as you are watching now, don't click on that like button. Click on that like button now, all right? And then do not forget to subscribe. Click on check now whether you have subscribed before. If your subscribe button is in red, that means you have not subscribed. Subscription is free, so what is the deal? Just click on the subscribe button, all right, so that you get notification anytime we publish a new content. And do not forget to share. So before we continue, this video tutorial is sponsored by the O3 School JAMB app. We're going to use the app now. I want to see a question from the application, a JAMB pass question 2023 number 37. 2023 number 37. It said, when a solute is fully dissolved in water and no more solute can be dissolved at that temperature. Okay, when a solute is fully dissolved in water and no more solute can be dissolved at that temperature, the solution is said to be A, they say saturated, B, unsaturated, C, dilute, D, concentrated. There are many questions we are going to see at the end of this class. This is one of them. All right, please stay to the end of the class. And please head over to Play Store immediately, download this application, and start practicing your way to success. It has all the past questions that you will need for your exam, so you don't need to go and buy past questions. It has a classroom feature that has lecture notes structured according to the JAMB syllabus, so you don't need to go and buy textbooks. Likewise, it also has the question search feature where you can search for questions according to topic. And likewise, there's the UTME mock challenge, JAMB mock challenge. Every Saturday, you compete with your mates, win amazing prizes, get used to JAMB past questions and likely exam questions. What's more, you see your results released every Saturday. Is that one not wonderful? All right, boost your confidence to all the main exam. And when they say JAMB don't release results, you know go. Yeah. All right. So let's begin we are going to begin with unsaturated solution. All right. An unsaturated solution is one that contains less solutes than the solvent can actually dissolve at a particular temperature. Okay. We say an unsaturated solution. I'm going to be slow in this class so that you get some important, because if you don't understand this, when we start taking calculations in solubility to be a problem for you. All right, so please understand each concept as we lay it down. All right, so say an unsaturated solution is one which contains less solute than the solvent can actually dissolve at a particular temperature. Okay, so we say an unsaturated solution is one which contains less solute, okay, than the solvent can actually dissolve at a particular temperature. Let's say the two very important words here are solute and solvent. Okay, and they'll talk about the solution that dissolve. Okay, so now let's say the solute is the substance being dissolved, right? A solute is a substance being dissolved. Okay, while the solvent is what actually dissolves the solute. Okay, so know that and know peace. First of all, let's say the solute is is salt or sugar. Okay, and let's say the solvent is water. All right, so now we cannot say when we put salt or sugar into water. Okay, let's say we put 1 spoon of sugar inside what? 1 big drum. All right, for example, okay. So now once you put that sugar, that's one spoon of sugar inside that big drum, even if you taste the drum, taste the water in the drum, will you taste any sugar? You may not even taste any sugar. It means that what? Even if you keep on adding more solute, more sugar to that drum, all right, it will still what? Carry, it will still be able to what? To collect what? More sugar, all right. That is an unsaturated solution. That means that solution is not what? Saturated. It can what? Still collect more what? Solute. All right, that's why we say that an unsaturated solution is one which contains less solute. The solute small. Okay, let me speak pidgin. The solute now, it is smaller than the solvent. Solvent many. Okay, why solute small? Okay, that means we fit still add what? More solute to the solvent so that it go dissolve them. You get? So that is what an unsaturated solution. Okay, is one which contains less solute than the solvent can actually dissolve at a particular temperature. Okay, this solution can dissolve more and more solute until it becomes what? Saturated. Okay, so this unsaturated solution can what? Dissolve more and more solute. You can be adding more solute to it. Okay, until it becomes what? Saturated. All right, so now I'm showing you a diagram explaining what? Both saturated, unsaturated, and a supersaturated solution. Okay, as you can see in the first case, okay, sugar was added to water, to the liquid, all right, and you see that what? It dissolved it completely. Okay, but just seeing very tiny particles of sugar. Okay, it dissolved it completely. That's the point. Now in the second diagram, okay, which is what? A saturated solution, you can see that what? You can see more particles of what? Of the sugar. Okay, you can see a bigger size of what? Particles of the sugar. Although it dissolved it, all right, it dissolved. It's just enough for saturated solution. Is just enough to what? To dissolve it. Okay, and of course, if you add more solute to a what? To a saturated solution, then you see that what? It will now start gathering at the what? At the bottom of what? Of the what? Of the container or the glass where you are what? You're adding what? Or the drum that you're adding what? That solute. At that point, it has become super saturated. That diagram alone is enough for you to understand what a saturated solution, what an unsaturated solution, and what a supersaturated solution what is. Okay, so now let's continue with our class. We say an unsaturated solution is one which contains less solute than the solvent can actually dissolve at a particular temperature. And an unsaturated solution can dissolve more and more solute until it becomes what? Saturated. Until it becomes saturated. Now, on the other hand, what is a saturated solution? A saturated solution is one that contains as much solute as the solvent. A saturated solution is one that contains as much solute than the solvent can dissolve at a particular temperature. Okay, in the presence of excess solute that is not dissolved. Okay, in the presence of excess solute, in the presence of excess solute that is not dissolved in the solvent. Okay, so that is what a saturated solution. A saturated solution is one that contains as much solute that the solvent can dissolve at a particular temperature. It's one that contains as much solute as the solvent. Okay, it's one that contains as much solute as as the solvent can dissolve at a particular temperature in the presence of what? Excess solute that is not dissolved in the solvent. Okay, so that is what a saturated solution. So now let's use our example of what? Of sugar and water. Okay, so you have water. You have your water, let's say in a glass like this. Okay, All right, then you now had, oh, this is water, this is water, this is water. Then you now had, oh, your solute, let's say sugar inside. Okay, now after you add, you kept on adding, it kept on dissolving, it now get to a point where it can no longer dissolve more solute. All right, at that point, the solution is what? Is saturated. Okay, so if you add more solute, even in that was saturated solution, you are still going to see some particles of sugar that did not dissolve completely. All right, just that they will not gather at the bottom of the container. Now I'm showing you that picture again. All right, you will see that for the saturated solution, the particles of the solute are pronounced. Okay, you can see them, but just that they did not gather at the bottom of the container. All right, but for a super saturated solution, all right, you will see very clearly that it has become saturated, and adding more solute will only lead to the particles settling at the bottom of that container. Okay, so that's why we are saying that a saturated solution is one that contains as much solute as the solvent can dissolve, okay, at a particular temperature in the presence of excess solute that is not dissolved in the solvent. In the presence of excess solute that is not dissolved in the solvent. Okay, this last line means that it's just the explanation of that particles that you are still seeing. Okay, you are seeing the particles there, but they did not dissolve again, because they can no longer dissolve again at that point. All right, the solvent has already dissolved as much as it can take. Okay, so those ones that just flying around, okay, randomly, okay, in the liquid. All right, so it did not dissolve, but it's not enough for it to start settling at the bottom. All right, that is a saturated solution. That is a saturated solution. This means that the presence of excess solute. This means that the presence of excess solute, presence of excess solute that is not dissolved in a solution, confirm its saturation. Okay, the presence, you are seeing these particles, okay, that did not dissolve, okay, in the solution. The presence of excess solute that is not dissolved in the solution, confirm its saturation. We confirm that solution is saturated. All right, the presence of excess solute that is not dissolved in the solution confirms the saturation of that solution. I'm showing that picture again. As you can see, in the first one, the particles are dissolved. Okay, it can take more solute. In the second one, which is saturated, okay, the particles have dissolved, okay, and it has taken more solute than it can actually dissolve. It has taken as much as it can dissolve, and then the leftovers are just those particles you are seeing that are more pronounced in the second diagram. Okay, but in the third one, which we are going to soon, we are going to see. So now we have said that the presence of excess solute that is not dissolved in the solution confirms saturation. It confirms saturation, confirms its saturation. Now, eating this solution now, okay, eating the solution causes all or part of the solute to dissolve. Okay, eating this kind of solution causes all or part of the solution to dissolve. All right, part of the solute rather to dissolve. All right, heating this solution will cause all or part of the solute to dissolve. Okay, now after heating, if you are cooling it down, cooling this solution that has not been heated, okay, will cause part of the already dissolved solute to crystallize out of the solution. Okay, we have already said that heating this solution, this saturated solution, heating, when you apply heat to it, it will cause part of the solute to dissolve, all or part of the solute to dissolve. Okay, now after you have heat it, if you want to cool it down, cooling this will cause part of the already dissolved solute, will cause part of the already dissolved solute to crystallize out of the solution, to crystallize out of the solution. All right, so please take note of those two. All right, so because sometimes we have to make calculations, okay, on crystallization, all right, or part of a solute that was crystallized, and so on and so forth. So it is very necessary to understand these terms. Okay, so like I said, as I repeat again, I say heating the solution causes all or part of the solute to dissolve, but cooling the solution will cause part, okay, of the already dissolved solute to crystallize out of the solution. However, there's an exception to this. Careful cooling of some of some saturated solutions. Careful cooling of some saturated solutions, like an example is what? Sodium thiosulfate. Okay, sodium thiosulfate pentahydrate. Sodium thiosulfate pentahydrate. That's what? Na2S2O3.5H2O. Okay, careful cooling of what? Of some what? Saturated solutions. Okay, such as what? Sodium thiosulfate pentahydrate. All right, will occur without crystallization what taking place, without the crystallization of the already dissolved solute taking place, or what going out of the solution. Okay, please take note of that. Careful cooling. This is an exception to what? Cooling what is saturated water solution. Careful cooling of some what? Saturated solutions, such as what? Sodium thiosulfate pentahydrate, that's Na2S2O3.5H2O. All right, will occur without what? Crystallization. Will occur without any form of crystallization. Okay, will occur without any form of crystallization of already dissolved solute out of the solution, of already dissolved solute out of what? The solution. Therefore, this kind of solution now tends to what? Have what? More dissolved. Now tend to have more dissolved solute. Okay, it now tend to have more dissolved solute. All right, than the solvent can actually take. Okay, so please take note of that. So careful cooling. I'll come back again and say careful cooling of what? Of some saturated solutions, such as what? Sodium thiosulfate pentahydrate will occur. Okay, will occur without any form of what? Crystallization of the already dissolved solute. Okay, out of the solution. All right. So now, because of that, the solution will now contain what? More dissolved solute than the solvent can actually take at that temperature. Okay, so it will now contain what? More solute than the solvent can actually hold at that particular temperature. And because of that, we now call that kind of solution what? A supersaturated solution. We now call that kind of solution a supersaturated solution. Supersaturated solution. Okay, that is this one we are talking about now. All right, so a supersaturated solution is a solution that actually has more solute than the solvent can actually dissolve. Okay, so it has more solute than the solvent can actually dissolve at a particular temperature, and because of that, it will now have the solute particles will now gather at the bottom of the container. Okay, the solute particles will now gather at the bottom of the container. All right, so that is what saturated, unsaturated, and what supersaturated solution is. Okay, so now to generate the excess dissolved solute from a solution, okay, to generate the excess dissolved solute, from a solution, okay, if you have a solution, all right, and then want to generate the excess dissolved solute, from a solution, what we do is we add a speck. We add a speck of the solid solute it already contains to it. Okay, we add number one, we add a speck. We add a speck of the solid solute it already contains to the solution. To it. Let me just say to it. All right. So now, remember, we are saying that we are saying that for a supersaturated solution, all right, the solution now has the solution now has more solute, okay, than the solvent can actually dissolve. Okay, so it has presence of more dissolved solute, okay, than the solvent can actually dissolve at that particular temperature. So if you want to generate, all right, we say if you want to generate the excess dissolved solute, from a supersaturated solution, what we do is we add a speck of the solid solute, okay, it already contains to that solution. If the sugar, I add a solid sugar. If the salt, you have a solid salt to it. Okay, you add a speck of the solid solute it already contains to it. All right. Then number two, we agitate the solution by shaking it. Number two, we agitate the solution by shaking it. All right, so we carry that solution we shake it together. All right, then of course, the third method, we scratch the bottom of the test tube with a spatula. Okay, number 3, we scratch the bottom of the test tube with a spatula. Okay, and then lastly, what we do is that what? We introduce a speck of dust. We introduce a speck of dust to act as the nucleation site. Okay, we introduce a speck of dust to act as the nucleation site, all right, for the excess dissolved solute. Okay, number 4, we add a speck of dust to what? To act as the nucleation site for the excess dissolved solute. All right. So if we want to generate the excess dissolved solute, what we do is add a speck of the solid solute it already contains to it. We agitate the solution by shaking it. We scratch the bottom of the test tube with a spatula, and then we add a speck of dust to act as the nucleation site, okay, for the excess dissolved solute. All right. So that is what saturated, supersaturated, and what unsaturated solution concepts. All right. So in the next episode, we're going to be looking at what solubility. But before we go, we're going to take some questions from the O3 Schools JAMB app. All right. There's one here from 2023, number 37, which says, when a solute is fully dissolved in water, please listen to questions and understand them more. They say when a solute, you put solute inside water, is fully dissolved, okay, and no more solute can be dissolved at that temperature. That means he don't receive the solute where if he was received. So if he no fit dissolve any more solute again, okay? So you should understand the language. When the solute is fully dissolved in water and no more solute can be dissolved at that temperature, the solution is said to be what? A, they say saturated, B, unsaturated, C, dilute, D, concentrated. Okay, that means it is already saturated. For it not to be able to what? To collect more solute, okay, to accept more solute, to dissolve more solute, that means that what? It has what? Gotten to what is saturation point. Now let's see another question, 2022 number 7. 2022 number 7. It says, dash of a solute at a particular temperature is one which contains as much solute as it can dissolve. Okay, that contains as much solute that it can dissolve at that temperature in the presence of undissolved solute particles. In the presence of undissolved solute particles. Dash of a solute at a particular temperature, okay, is one which contains as much solute as it can dissolve. It don't collect the solute when if he was receive. It don't really collect them, okay, at that temperature in the presence of undissolved, because for saturated solution, all right, it has receive as much solute as it can dissolve, but of course we're assisting with those particles there. So in the presence of undissolved solute particles, the particles are not gathering at the bottom, all right, but those undissolved solute particles are seen in the solution, all right. So that answer will also be a saturated solution. B, they say supersaturated. C, unsaturated. D, solvent. A, saturated solution is very correct. 2023 number 2 say, what is the solubility of a saturated solution? The solubility of a saturated solution is the maximum amount of solute that can dissolve in that solvent at a particular temperature. Is the maximum amount of solute that can dissolve at that specific temperature. All right. A, they say it is equal to 0. They say the solubility of a saturated solution is equal to 0. No. B, they say it is equal to the maximum amount of solute that can dissolve in that solvent at a specific or particular temperature. C, they say it is equal to the concentration of the solvent. No. D, they say it is equal to the concentration of the solute. No. All right. So it is of course equal to to the maximum amount of solute that the maximum amount of solute that the solvent can dissolve. Okay, at that particular temperature. That is a saturated solution. That is the solubility of a saturated solution. Now they say 2007-37, you say a supersaturated solution is said to contain a supersaturated. Say supersaturated, they get more solute, okay, than the solvent. Okay, and the solute will come gather for under. They say a supersaturated solution is said to contain a more solute than it can dissolve at that temperature in the presence of undissolved solute. It's not A, it cannot be A, because that is describing what saturated solution. B, say as much solute as it can dissolve at that temperature. Let's say saturated what? Solution. Okay. C, they say more solute than it can dissolve at that temperature. More solute than it can dissolve at that temperature. All right. That is what, of course, what a supersaturated solution is. It contains more solute than it can dissolve. So those ones now will gather what at the bottom of the container. So that is what option C. D say as much solute as it can dissolve at that temperature in the presence of undissolved was solute. All right, that still be what saturated solution. So the correct answer of what will be option C. Contains as much solute than what it can dissolve. Okay, at that what temperature. Okay, so please make sure that what you get your application. Make sure you like the video. Make sure you comment your questions and make sure what you subscribe to this channel. And we'll see you in the next episode where we'll talk about solubility. Thank you for watching.